I'm going to rewrite this. I don't expect you to do this every single time, but please put your pen or pencil down and just look at how I'm doing this. We have the radical, and we broke the 128 down to all primes. So we have this 2, and this 2. So I'm going to write 2 times 2 times 2. That's a cubed root. Now I have another set. I have 2 times 2 times 2. So I'm going to write 2 times 2 times 2 under my radical. And now I have this last 2. It's going to kind of hang out right here. And you can now clearly see that you have a perfect cube here, a perfect cube here, and since this one doesn't have 2 others, it's going to stay under the radical. So we have 2 that we can pull out from this one. We have another 2 that we can pull out from this set of 3. And then we simply have the cubed root of 2 because that one is standing alone. Now the third step said to simplify the outside. What that means is 2 times 2, you should never leave that as that, right? We can simplify that. So 2 times 2 is 4. And we take the cubed root of 2, and that is our final answer. Now, if at any moment you have a question, you must write it down. So when you get to class, you can ask it right away, okay? Next example, we are going to look for the 4th root. So the index in our next example is going to be the 4th root. So we're going to have tiny 4, taking the 4th root of 243. Now we are looking for a set of 4 numbers, right? One number multiplied by itself 4 times to get us something. So we're going to start prime factorizing 243. And now I'm going to just work a little more quickly, okay? So we have 243. I know that that is going to be 3 times 81. Circle the 3. 81 can be broken down to 9 and 9. And each of these 9 will be prime factorized to 3 times 3. For the sake of learning and notes, I'm going to rewrite this under the radical so you can clearly see how I'm bringing numbers to the outside. So I have 1, 2, 3, 4, 5 3s. So I have 3 times 3 times 3 times 3 times 3. That's the same thing as writing square root of 243. Now, since the index tells me that I'm looking for 4, a set of 4, I have a set of 4 3s right there. So I'm going to pull out a 3. What's left is this little guy, and he doesn't have any other 3 of the same friends, so I have to leave him under the radical. That's our final answer. All right, next example, last example for numbers, we have the 6th root. The index is 6 for 448. We are finding the 6th root of 448. Again, let's quickly break this down. We have 4 times 12. Times 112. Break this down so it's 2 times 2. This 112 can be broken down to 4 and 28. Quickly break this 4 down into 2 2s. This 28 can be broken down to 7 and 4. 7 is prime. Quickly circle. We have 2 times 2 for this 4. Now, we are looking for the same number repeated 6 times because the index again indicates that. So we have 1, 2, 3, 4, 5, 6 2s. So we're going to pull 2 out to the side. This 7, however, does not have another 7 repeated 5 more times. So we are going to rewrite this 7 under the radical with an index of 6. And that is the final answer. Alrighty, this is going to include our last set of examples. I will go over the absolute value with you again in class. So as long as you've mastered this, the absolute value shouldn't be too challenging. All right, so now we're going to deal with expressions including variables. But remember, variables are numbers, so the steps will be very similar. I will, however, repeat them because as you're learning, repeating won't hurt you. First step is to factor the radicand. I hope you're saying to yourself, oh, the radicand is what's under the radical into its prime factors. For variables, you obviously don't know what the numbers are, so you can't say, oh, it's 16, 4 times 4. But you can expand variables. So you will expand, which remember is the same thing as unsimplifying, expand the variables. Step 3, you're going to bring out the factors. So bring any factors. That are listed. The same number as the index. Four, simplify the outside. And the 5th step, this is what we're going to get to on Monday when you return, is absolute value. You must put absolute value bars on certain variables because you don't know if they're positive or negative. So when you have the square root of, let's say, b to the 4th power, and you're pulling out b squared, you don't know if b is -2 or +2. It could be both, but there are specific rules that we'll get to in class. So absolute value is the last step, but we will discuss that in class. All right, so let's do this first example. We have the square root, oh shoot. Okay, sorry about that. All right, so the first example is the square root of 12 to the x third, 12x third square root of that. So, like always, I like to focus on the numbers first because that's what we're trained to do best. So on the side here, I'm going to do quick work because remember on a test you can't just take forever trying to figure out or keeping something nice and neat. So you take that number out to the side and you practice that skill of prime factorization. So 12 can be broken down to 3 and 4, 3 being prime. 4 can be broken down to 2 and 2. We're going to circle both. Now, x, we are just going to expand. So under this radical here, I'm going to rewrite my 12 in terms of its prime factors. So I have 3 times 2 times 2. Then I have x to the third, which we know is x times x times x. I'm going to circle, since the index here, there's a hidden 2, I'm looking for the same number or variable repeated twice. So here I have a 2, meaning I'm going to pull that out. Here I have x listed twice, so I'm also going to pull out an x. What's remaining is 3x under the radical. Now, 3 and x, they don't have another partner that is similar to themselves, so that is actually our most simplified form. Now, again, I told you I will show you how to do this with the absolute value, but do not worry about that right now. So if you're thinking, wait, what if x is positive or negative or blah, blah, yes, you should be thinking in that direction, but I'm not going to go into it in this video. Okay, next example. We have the square root of 64 x to the 4th y. So, side work again. We have 64. We know this can be broken down with 8 and 8. And before I start further simplifying, I know I'm looking for two numbers that are the same that multiply to our target number. So if you didn't already see that 64 is a perfect square, which hopefully you should at this point, you can stop right there. We've accomplished our goal. So I'm going to pull out an 8. Inside my radical, we took care of the 64, remains x times x times x times x times y. Here, I have x listed twice, so I know I'm going to be pulling one x out from there. Here, I have another x listed twice, so I'm going to be pulling out another x. Y does not have another partner, so we're going to leave that under the radical. So we have 8 times x from the first set times another x from the second set, and under the radical remains y. Again, we have 8 times, you should never leave x times x, that way it's not simplified. So we have 8x squared radical y. Final answer. Okay? Now, I'm going to do 2 more examples with you, and that is it. So make sure you're taking good notes and you're trying to understand. I'll slow down a little bit for these last 2. The next example we have is the square root of 72, that is a 7, m squared n to the 4th power. On the side, we prime factorize the radicand, right? The actual number. That's step 1. So when we do that, we have 12 and 6. Quickly break down the 6 into 2 and 3. Circle, these are prime. 12 can be broken down to 6 and 2. Circle the 2. Continue breaking down the 6. Now we've broken it down to all prime factors, and I'll rewrite it for you under the radical. So again, you can clearly see what's happening. So I'm going to pair my 2's. So I have 1, 2, 3 2's, and I have 2 3's. Boom, boom. And then we have m squared, which is simply m times m. And we have n to the 4th, which is n times n times n times n. So let me just make sure that stays in the radical. There we go. I'm going to pair these off. So since, again, we have a hidden 2 here, I'm going to pull out a 2 from here. I'm going to pull out a 3 from here, because 3 times 3 is 9, square root of 9 is 3. Here we have 2 m's. Here we have 2 n's, and here we have another 2 n's. So we're going to start pulling these out. And I'm going to cross out as I go so you can see. 2 times 2 is 4,